Hi, I am Tunde and welcome to this tutorial where I demonstrate how to configure IPv6 Stateless Address Auto-Configuration or SLAAC using ICMPv6 Neighbour Discovery messages. Specifically, we'll see how router solicitation and router advertisement messages work to automatically assign IPv6 addresses. As you can see, I have a simple topology set up here in GNS 3. It includes two Ubuntu hosts, PCA as you can see on the top here, and PCB at the bottom. And I also have a router running FRR software. I'll be using Wireshark to capture ICMPv6 messages between the router and the two hosts, PCA and B. And as you can see here, I have the Wireshark capture placed right here. Alright, at the moment, let's go to the PCs. At the moment, both PCs have their network interfaces disabled. PCA on my left and PCB on my right have their network interfaces disabled, as you can see here. So for us to trigger a router solicitation message, I need to go to under the interface, network interface, on Ubuntu here. I go to the IPv6 tab, and it's already set to automatic. All right. So I want to get IPv6. The IPv6 method here or method here is for me to get IPv6 address automatically, not manually. So let's cancel that and then enable the interface. Right, so let us go back to Wireshark. Let's see what we have there. So if we go to Wireshark and place a filter like we always do for ICMPv6 messages, we can see here that there's a router solicitation message, 3 of them actually, but let us look at just one of them because they're all from the same link local address. And if we go, as you can see, this link local address ends with 3BD3. If we go back to PCA and we go to the command line and we type IP-6A, enter. Because we enabled the interface, we automatically generated the link local address, which ends with 3BD3, which was used to send our router solicitation message. So if we go back to Wireshark, because this is from PCA, and it's sent, the destination is to FF02::2. This is the multicast address for all IPv6 enabled routers on the local link. All right, FF02::2. Okay, so let us go to PCB and do the same thing. We just check the interface. Let's see if it's on the automatic. Yes, it's automatic. And then we enable the interface. Once we enable it, let us check the IPv6 or the link local address that's been generated automatically before we go to Wireshark. So we go to IPv6-6 or IP-6-A, and you see it ends. This is the link local address that has been automatically generated by PCB for communication on the local link. Now it ends with C6B0. So if we go to Wireshark, we see router solicitation messages coming from that particular node PCB, and it's sent also to all IPv6 enabled routers on the local link, this multicast address FF02::2. Okay, so how do we trigger a neighbor or a router advertisement? In this case, we go to the router. Let me clear the screen. Sort of commands here. Sorry, doesn't work in here. Let's clear the screen. All right, so I'm going to go into the global configuration mode. But before we start that, let's go back to the topology. Under the topology, you see the ETH0 interface on the router is the one connected to the switch, which the two IPv6 enabled nodes or hosts are connected to right now. So we're going to do our configuration on the router's ETH0 interface. So we'll go back to the router and I'm going to go on the interface ETH0. I'm going to hit enter and I'm going to assign two IPv6 addresses here actually. So let's say IPv6 address 2001 DB8 colon, let's put F00D :1 :1/64, our first IPv6 address. And the second one, let's just make this faster. We'll make this one face, FACE :1 and then we type in enter. So I want this router to send a route advertisement on its ETH0 interface. How am I going to go about that? So I'm going to type the command IPv6 ND for Neighbour Discovery. Let's check what we have here. We have the option prefix, which is what this one is, the one I'm going to use. Prefix. Then it says, what's the prefix? In this case, it's this prefix here. I want to add this one. So we're going to put that there. And we'll put a /64. And let's see what we have again. We have the no autoconfig. So what I'm going to do, I want the no autoconfig flag because I do not want the A flag to be switched on for this route advertisement. All right. So if I check now, I can press enter or the off link, but in this case, we want to press enter. So I'm going to hit enter, but that's still not done yet. I have to make this router advertise this prefix via route advertisement. And the way you do this on FRR is to say no IPv6 ND suppress route advertisements, and then you hit enter. All right. So let's go back to Wireshark. Let's see what we have there. So we can see here that we have a router advertisement sent on the router's interface. So ETH0 we configured on, but to confirm that, let us look at this carefully. Let's choose one of them. It's all from the same local link address or the link local address. So you see here, the source is this link local address, which I believe is the link local address of the ETH0 interface on the router. And this destination is to all IPv6 enabled nodes on the local link. All right, so let us confirm that. So this one that ends with FEE1:0, we go to the router and we look at interface, do show interface ETH0. We can see INET6, the link local address ends with that. All right. And then if we go to any of the nodes here, for example, PCA, if we change the A flag to M here, multicast addresses, we can see that every IPv6 node that has been enabled or enabled interface, it's going to join the all IPv6 enabled nodes multicast address, all IPv6 enabled nodes on the local link multicast address. All right. So if we go back to Wireshark, you can see here that this is the source, the link local address of the router's interface, and the router advertisement is going to all nodes or IPv6 nodes, enabled nodes on the local link. All right. And inside the router advertisement, if we look at some of the options here, you see we have the prefix information options. All right. So here we see the first one, F00D1. All right. It has a valid lifetime of this and the preferred lifetime of that. If we look at the one for face, the same thing here. If we expand it, the same thing. All right. So, but what we want to look at here, we want to look at the flags. So if we open this flag, all right, it says here on link, L not set. But what I did, if you remember, when I configured this prefix F00D, I said no autoconfig, meaning I did not want the A flag to be on. All right. So A flag is set to 0, but the default is the A flag is set to on. So because I did not do that for the second prefix here, the face prefix, the DB8FACE:1, if you check the flags here, you can see the A flag is set to 1, meaning all IPv6 enabled nodes can use this prefix to automatically generate an IPv6 address. they cannot use this one because the A flag is set, is off. They cannot use this one, the one with F00D or 00D, to set an IPv6 address. So the way we can confirm this is to go to the nodes, or the PCA and PCB, to confirm. PCA and PCB should have generated temporary and permanent addresses with this prefix FACE, but without this prefix F00D. All right, so let us confirm that. If we go to PCA, for example, and we type this, change this back to A, we can see here, like I said, we have a temporary address, FAC1, this prefix, it's a temporary address, and this is the global address itself, but also the same thing, FAC. All right, but the F00D was not the case. If we go to PCB, let's try that also. Let's see what we have there. PCB also has generated its IPv6 address, a temporary one with the face prefix and the interface identifier random here, as you can see. And PCB also has generated a global address, the permanent one, using the same face, but without the F00D. Okay, so if you remember, let's go back to the router. Remember, I said this configuration, no autoconfig. That's why when PCA and PCB received the router advertisement with that prefix in it, with the A flag off, they did not use it for autoconfiguration. But for the other prefix that was configured under the interface, this one, face, it had the A flag on by default on FRR software, and the nodes will use that to automatically configure. So let us take a look at the Wireshark again, just to drive this home, and then we close this session. So as you can see here, this is a router advertisement sent from the source is the link local address of each H0 of the router, sent to all IPv6 enabled nodes on the local link, which PCA and PCB were tuned into. It's a multicast address. And if you open the prefix information option in the router advertisement, you can see here F00D prefix, which I set to no autoconfig, has the A flag, autonomous address auto-configuration, A flag to 0, meaning it's off. But this one, the FACE :1, is on by default. I didn't switch it off. So if you go to the flag, you can see here it is on. All right. So, and when we check the nodes, we saw that they all have the IPv6 address generated with the prefix. They had the autoconfig flag on, set to 1. All right. So we can see here the router sent a router advertisement out to in a response to the router solicitation from PCA and PCB when they were set to automatic, and they automatically generated an IPv6 address using the prefix inside the router advertisement. And that's how you configure IPv6 SLAAC using ICMPv6 Neighbour Discovery messages. We've seen how router solicitation and router advertisement work together to provide automatic address, and how flags like the A flag control auto configuration. If you found this video helpful, please like and share and subscribe for more tutorials. Thanks for watching.